Hello, this is Dr. Ayanshola Ogunile, Astronautics for Exploit. Space-based resources, sources of economic wealth and sustainable space exploration. The focus points of my presentation are as follows: space resources, in-situ resource utilization, space resources mining, and past and ongoing missions about space resources. The universe, all of space and time, and their contents such as planets, stars, galaxies, and all other forms of matter and energy is made up of various potentials and resources. Human beings are dependent on various of-world resources of the universe. Virtually, the energy we use on Earth comes from the sun, and the magnetosphere resources protect us from dangerous solar radiations. Beyond Earth's atmosphere lies a region that has benefited us and is still benefiting us up to today. This region, where low Earth orbit, medium Earth orbit, and geostationary Earth orbit lie, contains communication satellites, Earth observation satellites, International Space Station, and a host of others, and has provided economic wealth to the space agencies, private space companies, and investors. The remote exploration of the planets, moons, asteroids, and comets have been made possible by the human persistent interest in space exploration and advancement in robotics and automation technologies. The growth in humans' usage of resources and the need to enhance our scientific knowledge necessitated the need to explore extraterrestrial resources. Space-based resources such as metals, rare earth elements, volatiles, solar radiation, raw materials, and natural resources that are abundantly available in space. These resources will help in achieving continuous and sustainable exploration of the astronomical objects such as the Moon, Mars, and asteroids. According to research findings, Mars is said to be abundant in metals such as magnesium or aluminum. Volatiles are found in comets and asteroids materials that are trapped on the lunar poles. On Mars and other planets, volatile molecules are released from the crust and planetary interior into the atmosphere via volcanic plumes. Research evidence shows that there are the presence of iron-nickel alloys, hemenites, silicates, and volatile-bearing minerals on asteroids and comets. The Moon is said to contain regolith and lava tubes. For many years, several space missions and endeavors have been targeted at investigating presence of various resources on astronomical bodies. The Lunar Reconnaissance Orbiter indicated the presence of water ice buried under the lunar regolith at certain locations. The Volatiles Investigating Polar Exploration Rover is designed to get a close-up view of the location and concentration of water ice that could eventually be harvested to sustain human exploration of the Moon, Mars, and beyond. Lunar Flashlight is a very small satellite being developed to use near-infrared lasers and an onboard spectrometer to map ice in permanently shaded regions near the Moon's South Pole. Space resources. Space resources are classified as follows: metals, rare earth elements, volatiles, solar radiation, raw materials, and non-metals. Space resources. Space-based resources are natural resources that are abundantly available in space. According to the research findings, orbiters and rovers, a lot of rich resources can be found on the Moon, Mars, comets, asteroids, and a host of others. This picture shows Volatiles investigating polar exploration rover. Metals. Metals on astronomical objects are present in silicates, halcites, meteorites, carbonates, and meteorites. Examples are iron, nitrogen, aluminum, and magnesium. S-type asteroids are made of an anhydrous rocky material. They are brighter than C-type asteroids and the most abundant type in the inner portion of the main bed. According to findings, Mars is said to be abundant in metals such as magnesium or aluminum. Iron is abundant in all mere basalts, but is mostly locked into silicate minerals. This picture shows artist's concept of NASA astronauts on an Artemis mission landing. Volatiles. Volatiles are molecules that readily evaporate and convert to their gaseous form, such as water and carbon dioxide. On the Moon, volatiles are found in comets and asteroid materials that are trapped on the lunar poles. Volatiles from permanently settled craters may provide methane, ammonia, carbon dioxide, and carbon monoxide. This picture shows craters near the Moon's poles. On the Mars and other planets, volatile molecules are released from the crust and planetary interior into the atmosphere via volcanic plumes. On Mars, significant amounts of carbon dioxide go back and forth between polar ice caps and the atmosphere depending on the season. Volatiles are from polar ice, subsurface ice, and hydrated minerals that are present on the Mars. This picture shows thorium concentrations on the Moon. On the asteroids, research evidence shows that there are the presence of iron-nickel alloys, silicates, ilmenites, and volatile-bearing minerals. On the comets, the main abundant volatiles in comets are found to be in water, which is invariably the dominant volatile, which come in a wide variety of abundances, up to tens of percent. A beautiful mosaic of asteroid vista is shown in this picture. Rare earth elements. The magma ocean on the Moon is said to have rare earth elements. Creep are parts of the lunar surface richer in potassium, rare earth elements, and phosphorus. This picture shows thorium concentrations on the Moon as mapped by Lunar Prospector. Solar radiation. Solar radiation, an exterior heat source of the Moon, controls the variation of the temperature of the surface of the Moon. It alters the thermal radiation properties of the lunar surface. Solar radiation is a very important factor to be considered before embarking on Moon missions. This picture shows proposed future Moon bases to be covered with a layer of lunar regolith so as to protect against radiation from space. The surface of Mars is exposed to higher levels of radiation than Earth. In addition to regular exposure to cosmic rays and solar wind, it receives occasional lethal blasts that occur with strong solar flares. Radiation exposure on Mars. Studies show that prolonged exposure to the radiation levels detected on Mars could lead to various health problems like acute radiation sickness, increased risk of cancer, genetic damage, and even eventual death. This picture shows a diagram of the amount of cosmic radiation the surface of Mars is exposed to. The nearest large near-Earth asteroid is 1036 Ganymede, and this asteroid could maintain a dust cloud large enough to block out 6.58% of solar radiation that would normally reach Earth. This could help to combat any current global warming trends. This picture shows a proposed concept of a dust cloud made of asteroid material for cooling the Earth. Raw materials. Examples of raw materials on the Moon are regolith and lava tubes. On the Moon, regolith occurs as a mixture of, powdery dust and broken rock. Lunar regolith is formed by the impact of meteorite on the body's surface. The surface of Mars is covered by sand and dust, formed by the erosion of iron-rich igneous rocks that are like basalt. Known as regolith, this material can be coarse or fine, or an incredibly fine powder-like dust. This picture shows Curiosity's view of Martian swell and Buddha's ether crossing the Dingo Gap sand dune. Non-metals. Non-metals are found on the Moon, Mars, and asteroids. They are present in oxides, silicates, sulfates, and phosphates. This picture shows surface features of the northern and southern hemisphere of Mars. In situ resource utilization is an approach by which resources found on the Moon, Mars, asteroids, etc. are mined, manufactured, and transformed into valuable resources, which can be used to reduce or totally eliminate the need to wait for materials to be brought from the Earth. This picture shows artist's concept of the Lunar Gateway spacecraft. Space resources mining. Space resources mining. An excellent understanding of the space resources geology and physics is necessary in order to be able to mine and use space resources. There is the need to develop mining instruments and advanced technologies for space resources survey, mining, and processing. This picture shows concept of rocket mining system. Space resources mining, mining instruments. Examples of instruments that can be used to mine space resources are robots for scooping icy swell on the Moon, or machines that can thermally extract water and organic volatiles from the clay minerals of carbonaceous asteroids. This picture shows an illustration of a lunar polar mining base with buried crew habitats. Past and ongoing missions about space resources. Some of the missions that focus on looking for space resources have been put forward. Over the years, several space missions and endeavors have been targeted at investigating presence of various resources on astronomical bodies. Through various missions, it was discovered that astronomical bodies are made up of various resources which are potential sources of immense economic improvement. This picture shows lunar near side. Resources investigation. The various missions that carried out investigation about space resources are as follows: Lunar Reconnaissance Orbiter, Volatiles Investigating Polar Exploration Mission Rover, Lunar Crater Observation and Sensing Satellite, International Coordination of Lunar Polar Volatiles Exploration, Lunar Flashlight, Lunar H-Map, Lunar Ice Cube, NASA's MOSI, or Mars Oxygen In Situ Resource Utilization Experiment. This picture shows illustration of lander on the Moon, deploying Viper ice hunting rover to the Moon's South Pole. Lunar Reconnaissance Orbiter. The Lunar Reconnaissance Orbiter is a robotic spacecraft currently orbiting the Moon in an eccentric polar mapping orbit. The Lunar Reconnaissance Orbiter has returned highest quality images and a treasure trove of data from the lunar surface that indicate the presence of water ice buried under the lunar regolith at certain locations. This picture shows artist's concept of NASA's Lunar Reconnaissance Orbiter. Volatile Investigating Polar Exploration Rover. The Viper is a mobile robot that will go to the lunar South Pole in 2023 to get a close-up view of the location and concentration of water ice, which could eventually be harvested to sustain human exploration on the Moon, Mars, and beyond. Viper represents the first resource mapping mission on another celestial body. This picture shows an artist's concept of NASA's Volatile Investigating Polar Exploration Rover. The Lunar Crater Observation and Sensing Satellite mission, launched along with the Lunar Orbiter, was directed to impact the lunar surface. Observations of the resulting 10-mile-high plumes show that nearly 5% of the regolith was composed of water and another 5% contained additional volatiles, including methane, ammonia, hydrogen, carbon dioxide, and carbon monoxide. This picture shows artist's rendering of the Aircross spacecraft and Centaur separation. International Coordination of Lunar Polar Volatile Exploration. NASA and other space agencies are conducting international coordination of lunar polar volatile exploration to increase scientific knowledge to determine their viability as potential resources and to use the Moon as a proving ground for Mars in situ resource utilization technologies. This picture shows concept image of lunar flashlight in a position over the South Pole of the Moon. Lunar flashlight. Lunar flashlight is a very small satellite being developed to use near-infrared lasers and an onboard spectrometer to map ice in permanently shadowed regions near the Moon's South Pole. Lunar flashlight, a technology demonstration mission, will showcase several technological firsts, including being the first mission to look for water ice using a laser reflectometer and the first planetary CubeSat missions to use green propulsion, a propellant that is less toxic and safer than hydrazine, a common propellant used by spacecraft. This picture shows artist's concept of lunar flashlight spacecraft. Lunar map. Lunar map, a planetary science mission, is a miniaturized, fully functional interplanetary spacecraft that will map hydrogen enrichments within permanently shadowed regions of the lunar South Pole. Lunar H-map will measure the abundance of hydrogen using a new type of compact neutron spectrometer. Neutron measurements made at low altitude over the lunar South Pole will allow Lunar H-map to constrain the hydrogen within permanently shadowed regions at unprecedented spatial resolution. This picture shows lunar South Pole. Lunar ice cube is another mission findings about space resources. It's designed to search for water ice and other resources at a low orbit of only 62 miles above the surface of the Moon. It is one of two secondary payloads NASA selected through the Next Space Technology for Exploration Partnership. This picture shows lunar ice cube. Mars Oxygen In Situ Resource Utilization Experiment is another mission designated for space resources. MOSES, which is to be launched on the Perseverance rover, is being executed in preparation for future exploration of Mars. It is designed to demonstrate how future Mars explorers might produce oxygen from the Martian atmosphere for propellant and breathing. This picture shows Mars oxygen in situ resource utilization experiment. You've been watching and listening to Space-Based Resources, Sources of Economic Wealth and Sustainable Space Exploration, presented by Dr. Anyashola Ogundele, Astronautics for Exploit. Thank you.